Alright everybody, so today we're going to do experiment 2.5, and our focus question for today is, why do stars appear to move across the night sky? And so I want you guys to ask yourself a couple questions. Did any of you see the sun come up this morning? Right? If so, where did it rise? Alright, good, you're right, it did rise in the east. Did anybody see the moon yesterday, or maybe today, or any time in the past week? If so, when did you see it? What did it look like? And did you observe anything maybe else in the sky? I don't think there's been any planets. Well, there might have been one, but I wasn't outside to see it, so I'm not going to count that for at least me. But I know I've seen the stars when I go outside, and I know that we've all seen stars at some point or other. But what really is a star? Alright, so in our notes, we are going to write for 2.5, a star is a ball of burning gas that gives off light and heat. Our sun is a star. It is very much like the hundreds of tiny, bright spots of light you see in the night sky. Alright, why do you think that the stars in the night sky are so small? And some of you, I think, probably know the answer to this, but some of you might not. Why do you think that they look so small for us? Alright, good. Stars are very, very far away from Earth. They're so far away that it takes years for light to travel from that star all the way to Earth. And it takes light 8 minutes to go from the sun to the Earth. 8 minutes for the sun, okay, our light from the sun to reach Earth. The fastest jet airplane ever made can fly at 3,327 kilometers per hour. It would take that jet over 1 million years to fly to the closest star beyond the sun, and that's at about 2,067 miles an hour. So a jet flying at 3,327 kilometers per hour, or 2,067 miles per hour, would take, okay, we're going to do million years plus to get to the closest star beyond the sun. Alright, imagine how far those must be away if it really does take that long for us to fly there. So, when you guys have looked out at the night sky, and have you ever seen, maybe something, stars, they appear in little groups? Alright, and when you look up at the night sky, you can see around 2,000, maybe more stars. And they are spread out, absolutely everywhere, but they do seem to be sometimes grouped in small little places. A constellation is an array of stars that form An identifiable pattern. And constellations are going to have different names that describe an object, a person, or an animal. So, object, person, or animal. And I bet you guys can even name a couple right now just thinking about it. Maybe you don't know the quite name, but you've seen some of those stars, and you've maybe come up with your own names. So what we're going to do is we are going to look at, and let me get my page, we are going to look at this one. Okay, this is the Big Dipper. All right. And you guys are going to see this usually, or you're always going to see it in the northern sky. And people long ago thought that this pattern of stars looked like a dipper or a ladle, you know, something that you put into water to drink out of. And a dipper is essentially a cup with a handle, or a cup with a long handle. People use dippers to dip water from a bucket or a pool to drink out of. And the Big Dipper is actually it's part of an even larger pattern of stars called Ursa Major. And Ursa Major is Latin for Big Bear, or the Great Bear. And so we're going, let's find here. Here's Ursa Major. All right, and if we look very closely, we can see here is the Big Dipper, and here's the rest of the stars. Now these stars, people thought, formed a pattern. Now maybe you guys can see something. I don't know if I quite see a bear, but I can see that there might be something here. All right, maybe there's feet here. I'm leaning towards maybe a fox, though I have seen a lot of raccoons, so I might think it's a raccoon. But they have called it the Great Bear. All right, here's the Big Dipper. All right, is the tail and the body, and the rest of the stars form the body of the bear. And this constellation has a story behind it. So you notice that this picture, you see how the bear has a really long tail? Bears don't usually have long tails, but there's an old story. It's an old made-up story that explains how the bear once had a long tail and then he lost it. A long time ago, Bear had a lovely long tail that he was very proud of. He used to wave it around and make the other animals look at it. For Fox decided to play a trick on him. It was winter and the lakes were frozen. Fox tricked Bear into using his tail to go ice fishing. Bear put his tail through a hole in the ice, hoping that a fish would come on it and grab his tail. Then he could pull the fish out and have it for dinner. Bear waited there so long that he got tired and fell asleep. Night came, and ice covered the hole. Bear's tail was frozen into the ice. When he tried to pull his tail out, it broke off. He left his long, lovely tail in the ice. So to this day, bears have had short tails and are not very fond of foxes. All right, and as we know, this is a myth, but it does give, it is a way for some of our ancestors, this is the story they came up with to explain why bears have short tails now. All right, so many years ago, people would look at constellations, patterns of stars that reminded them of things or stories that were part of their daily lives. And they would see these same patterns of stars night after night. So knowing where the stars would be every night helped them find their way, both on land and on the sea. They named these patterns of stars or constellations as a way to remember them and refer to them when they talked about stars with other people. All right, so let's look at page 11, the star patterns, all right, this empty one. And so here are 6 random patterns of stars. And what I want you guys to do here is to connect the stars in some way and come up with your own patterns. They can be completely unique to you. All right, I will leave you guys, or they're not made up stars. I misspoke. They're real constellations, but you guys don't know the pictures, so I want you guys to create your own. All right, name them however you want, and I want you guys to create a picture. All right, and I will let you guys work on that for that few minutes. So, so our focus question, though, today is, why do stars appear to move across the night sky? All right, so if we're looking at the night sky and we see it, we're not always going to have the exact same constellations in the same place, all right? The stars are not going to be in the same place. The patterns of stars that we see today as Ursa Major is exactly the same pattern of stars shepherds in Greece saw 3,000 years ago. They actually haven't changed position at all. So when you guys go outside and look at the stars, the constellations do not change. The stars and the constellations, they don't move. What happens is that the whole constellation does move, all right? So individual stars aren't going... I'm messing this up. I'm sorry, guys. Whole constellations are going to move. So, like Ursa Major is going to move. And if you stay out all night, you will see the constellations rise in the east, travel across the sky, and set in the west. So why do you think that they do this? All right. So what happens is that our solar system is surrounded by millions of stars. Stars are positioned all around us. The stars around us do not move. That's why the constellations are always in predictable patterns and locations of the sky. But remember that the Earth is moving. All right, remember how, the sun doesn't move. The stars do not move. Stars do not move. But we move. Our Earth is constantly moving. All right? So, Earth rotates on its axis once every day. When we look up at objects in the sky, they look as if they're moving. But really, we are the ones that are doing the moving. It's like looking at trees going by when you are riding in a car. The trees aren't moving, but they show up in the front window, go by on the side, and then disappear behind. Watching stars is essentially the exact same thing. They rise in the east, go overhead, and set in the west. And so what we're going to do is, I want you guys, we're going to look at this picture of Orion. All right, it's a constellation. So, everybody, stand up in front of your computer and put your hands like this. And we've already done this a little bit in class, so you guys should kind of remember. All right, so step one is to turn away from the computer. Step 2, move a little bit more. Step 3, face it and look at the picture. Step 4, and step 5. All right, and the only time that we see, like I would see Orion, is when I'm facing it. All right, so because remember the Earth is revolving, or sorry, the Earth is rotating, not revolving. All right, you guys are only going to see it when the Earth is positioned towards it. And then there's some different things that we're going to talk about. We're going to discuss seasonal constellations. Now, remember, constellations don't move. They stay in one place in the sky. But if you go out shortly after dark in the middle of in the winter, you will see Orion. All right, so Orion, winter constellation. And if you go out at the same time in the summer, all right, so I go out in the middle of the night in the winter and I see Orion. Now, if I go out in the middle of the night at the exact same time in the summer, I'm not going to see Orion. Instead, when you look up in the sky, you're going to see Aquila, the eagle. So Aquila is the summer constellation. Do you remember why it's like this? Sorry, everybody. Lost my place. What we're going to do is think of it like this. All right? In the middle is the sun. And here is our Earth. At 4 different times of the year. Fall, winter, here's the spring, and the summer. So when I'm going to pretend I'm the pen, when I'm standing here in the summer, I can see Aquila. All right, and then we go from summer into fall. So the Earth, remember, is rotating. All right, it's rotating as it revolves around the sun until we get to the summer. All right, so the Earth is in a different position of the sky in the summer, right? So we're not going to see the same stars. So in the summer, I see the summer constellations. And in the winter, I'm going to see Orion. And then in the spring, I'm going to see something else. And then we're going to come back to Aquila. So how this works is, so here's our sun, right? And there are millions of other stars all around the sun. Imagine there are millions of them in this direction, such as in front of us or behind us, whichever way. And just, if you look one way, you are going to see different stars during the different seasons. All right? Let's see. Now, some things that I want you to remember. Stars do not move. All right? We can only see the stars when it's dark, and that the Earth is rotating as we revolve around the sun. We see different constellations during different seasons. Because of the Earth's position around the sun. And so for what I want you guys to do today is, after you have done, after you guys have done the readings and answered the questions, there is a video that's all about stars. You can find that in the FOSS, under viewing videos, something like that. And that's going to take you guys about 24 minutes to do. And just, if you guys have any questions, make sure that you guys are asking. I know this is a lot of information. I hope that you guys, what I'd really like for you guys to do is, since we, can't get together and it's more difficult for us to see each other, I would really like for you guys to go outside at night, and I would like you to pick a constellation. Maybe it's just a certain star that you decide that you can find, and I want you to see, does it move, all right? And I want you to go outside every single night and just try to find this star and see how it looks like it's moving, but really we're moving, all right? And this is just kind of my challenge for you guys to just kind of see how this actually happens, all right? How we go from spring into the summer constellations. So I hope you guys are having a great week, and I will see you guys later. Bye.